All right, so now we're looking at 3D problems. So in this question it says, the diagram below shows a rectangular box, and you can see it's in 3D, with the top A, B, C, D, and the base E, F, G, H. Okay. The distances are indicated on the diagram, so it's 3 centimeters high. It's, oh, I'm going too fast here. It's 5 centimeters wide, 12 centimeters long. So the first thing they want is the distance BH. So that's B to H. So they want the distance from the bottom corner to the top corner. All right, so what we do first is we have a look and we draw. Our blue line shows that. Our red line goes along the bottom, and we're looking at the angle. So it says find FH first, and then you can find the BH. So the FH is flat across the floor, okay, from that corner to the bottom corner. Now, we would be able to find that because we've got a straight line, and this over here would be our right angle. So we would be able to use what we know in order to find out that right angle, which would be HFG or GFH, okay. So here we go. FH squared, so that's obviously because that's our hypotenuse, is equal to 12 squared, which is equal to 5 squared. We're doing Pythagoras. Okay, FH, the square root of FH, and we get 13 centimeters. So now we know that from there to there is 13 centimeters. Okay, great, perfect. Now we can use that to continue on. So now we're going BH is, so the square, so now we know this side, BH is 13 squared plus 3 squared. So that's our height. So now we're looking at the triangle from the side. So here we've got our square root, our right angle, our one side, and then this will be our hypotenuse on this side. Okay, we'll use Pythagoras again, and we'll get that BH is 13.3 centimeters. So now we've got BH, which was, we wanted A. Perfect. Next thing we have to do is we have to find the angle FHB. So let's see where that is. FHB. So it's that triangle that we've got there. Well, from the triangle FHB, we know that we're looking for tan, because we find out what the sides we've got. Tan, which we 3, which is our height, divided by 13 over here. So we've left out the hypotenuse, so 3 divided by 13, and we get angle of 13 degrees. So you just have to look at this differently. I'll do one more with you. So in this example, the diagram below shows a wedge in which the rectangle ABCD is perpendicular to the angle CDEF. So CDEF, okay? The distances are indicated on the diagram. Find the diagram to find the distance BE. So where's B? BE. Okay. First thing we're going to do is draw our lines. Now, the first line we're going to find is our EC. Find EC first, and then we find BE. When we find EC, we use Pythagoras, because we know that that's 5.4, we know that's 9.2, so we find Pythagoras, and we come up that that line here is 10.67. Now what we do is we can use it from the side, and we can take that right angle and do it again to find out the angle of this side. Okay, so now we're going to do Pythagoras again, so we can find out what our hypotenuse is. There we go, 11.1 meters. So there we go. Now we're able to work it out to find out what our angle is. So from triangle CEB, we know that it's tan because we're wanting to find this here, and angle CEB is 16.2. Now just remember, when you're doing this, I want you to show all your working out, okay? And remember to call each angle what they are named, all right? So that we know what you're talking about. All right, I want you to go ahead and try this for me.